In an important step toward bringing transparent solar cells to home windows, researchers at the University of Michigan have developed a way to manufacture their highly efficient and semi-transparent solar cells. In principle, we can now scale semi-transparent organic solar cells to 2 meters by 2 meters, which brings our windows much closer to reality, said Stephen Forrest, the Peter A. Franken Distinguished University Professor of Electrical Engineering and corresponding author of a study published in Organic solar cells have lagged behind their silicon-based cousins for energy-producing purposes due to engineering challenges such as low efficiency and short lifespans, but recent work out of Forrest's lab has achieved record efficiencies of 10% and estimated lifetimes of up to 30 years. So the team has turned its attention to making transparent solar cells manufacturable. A significant challenge is creating the micron-scale electrical connections between individual cells that comprise the solar module. Conventional methods that use lasers to pattern the cells can easily damage the organic light absorbers. Instead, the team developed a multi-step peel-off patterning method that achieved micron-scale resolution. They deposited thin films of plastic and patterned them into extremely thin strips. Then, they set down the organic and metal layers. Next, they peeled off the strips, creating very fine electrical interconnections between the cells. The group connected 8 semi-transparent solar cells, each 4 cm by 0.4 cm and separated by 200 micrometers wide interconnections, to create a single 13 square centimeters module. The power conversion efficiency of 7.3% was approximately 10% less than for the individual solar cells in the module. It is now time to get industry involved to turn this technology into affordable applications, said Xinjing Huang, doctoral student in applied physics and first author on the published research. Eventually, the flexible solar cell panel will be sandwiched between 2 window panes. The goal for these energy-generating window films is to be about 50% transparent with 10% to 15% efficiency. The technique can also be generalized to other organic electronic devices, he says. And in fact, his group is already applying it to OLEDs for white lighting. The University of Michigan has applied for patent protection and is seeking partners to bring the technology to market. Forrest is also the Paul G. Goebel Professor of Engineering and Professor of Electrical and Computer Engineering, Materials Science and Engineering, Physics and Applied Physics. Co-author and assistant research scientist Yongxi Li assisted in the fabrication of the devices, which was accomplished in the Lurie nanofabrication facility. The research was supported primarily by the U.S. Department of Energy. Additional support was provided by Universal Display Corporation. Forrest and have a financial interest in Universal Display Corp. Materials provided by University of Michigan. Original written by Catherine June. Note: content may be edited for style and length. Xinjing Huang, Dejun Fan, Yongxi Li, Stephen R. Forrest. Multi-level peel-off patterning of a prototype semi-transparent organic photovoltaic module. https://ift.tt UPLJHXZ. Accessed July 19, 2022. Thanks for watching. Please subscribe my channel for more videos.